So this talk is titled In-Place Pod Resize. And my name is Mofi. I have here
Tim Allclair.
So we're going to talk to you about what In-Place Pod Resize is all about and why potentially it would help you and why we should care. All of us know what HPA is, yes? HPA, more or less? Yeah. HPA, horizontal pod autoscaler, the basic idea is you have a deployment that has some number of pods and some signal happens. It could be you're using too much CPU, too much RAM, external resources like Kata telling you that you need more pods, and the controller then spins up more pods. You have more copies of the same pod serving the request. Great. There's another one, right, you have heard of in the past potentially, called vertical pod autoscaler. VPA is the same idea, but instead of saying I need more copies of the pod, you are saying I need this same pod that is serving request to be bigger, right? So how many of you use VPA in production today? All right, fantastic. Do you like using VPA in production? Good. If you do, that's good. But if you don't, the reason you might not like using VPA in production, the challenge with VPA there is when VPA scales up the pod, it kills the old pod and spins up a new pod, right? So if you have any application that requires the pod to stick around during the resize, VPA at this, as of last month, VPA did not actually do the thing you wanted it to do. There are other use cases, for example, like game servers. People are connected to your game. If you just kill that pod to make a bigger pod, some people might be angry, right? Like playing their games. Efficient bin packing, if you have a node, you want to use the node to the fullest capacity. If you could feed the right amount of resource just by sizing it bigger, fantastic. You can get more out of your resources. Pre-warmed worker. So you have a worker that is, let's say, using some resources, and then when they're not being used, you can shrink them down. And when they're getting used again, you can scale them back up. So that way, you don't have to use the resource all the time, but only when you need them. And finally, startup boost. Anybody have application written in something like Java running on Kubernetes? Right, so anything that is just-in-time compiled or just-in-time runtime, what happens is during startup, it requires more resources because it has to do some calculation then. But once the application is in fully running state, it actually does not require as much resource. But today in Kubernetes, you kind of have to give the resource it needs to start because otherwise you're going to get OM killed before you even start your application. So for that kind of application, having VPA is actually very powerful. Being able to scale your application down after the application is in running state is very useful. So for solving all of those problems and more, introducing In-Place Pod Resize. So what that is a way to resize your pods, as it says in the name, in place. The way you use it, if you're a fan of kubectl CLI, is just kubectl edit pod with a sub-resource resize. You can just send this command, and that would resize the pod, potentially in place. It doesn't do in place all the time. There is a way, again, by default, it is in place, but you can set a thing called resize policy. So if you have an application that you say, if the CPU gets resized, I don't want it to restart. But if the memory gets resized, I want to restart, right? So let's take a look at the demo real quick before we go any further. I have a terminal set up here, so get po-and IPPR. So I have an application. Look at the one in the bottom. The top one is just a placeholder thing. We're going to take a look in the later. But I have this application here, this IPPR, which is currently running. If I take a look at -o YAML, you would see I have this resize policy block here that is defined, which says CPU, not required, memory, restart container. So I'm going to send a command, so kubectl. Okay, so I have to export the. Oh no, it's name change. Hold on. I gotta set a variable first. So if I do kubectl patch, kubectl patch pods. So what I'm sending here, I'm sending a resize patch request and sending an object of what I want the resources to resize to. Actually, instead of sending it here, I should probably do it on this side. So I can do a watch on the first. So what I'm watching for is on my pod, or not this watch, hold on. Run the command first, and then try to do this, but instead of doing this watch, it doesn't look like this one. I'm going to do -w. Oh, what did I do?
Change pod name.
Pod name. Okay, hold on. Okay, get po-and IPPR. Copy this one. Go back to this one. I got to change the pod name. Pod got recreated with a different name. So do this one. So I'm basically running this watch command that looks at the resource. So things you're looking at here is my limit and resource are set to both 0.5 CPU and 500 megabytes of RAM. And the status condition is pod ready to start container. So pod is ready. And my allocated is how much resource actually is in my pod is also the same as my requested. Now if I were to make a, okay, I'm gonna have to copy the pod name again. And if I were to run this command now again, patch pod, with the pod name, what I'm saying is instead of having the 0.5 and 500 megabyte, I want 8.8 CPU and 1 gigabyte of memory. And the other thing would be nice to have is watch kubectl get po dash and IPPR. So I'm gonna keep a watch on the pod, and once I run this command, few things are gonna happen. One is we're gonna see some changes happening on the top. And the other thing that just happened is I have a restart here on my pod. The pod just got restarted because, again, in this case, I changed the memory that I was asking for, right? So in a second, restart happened, my pod restarted, everything is good. If I were to make another request here, but this time, instead of changing the memory, I only am going to change the CPU to 600, maybe, that's fine. Both limit and request to 600. That happens, and that happens real time. That doesn't actually restart the pod. Because again, in my configuration, I said CPU, do not restart, memory, do restart. So that's kind of, we're gonna come back and see a little bit more demos in a second, but I'm gonna pass the microphone off to Tim.
All right, thanks, Mofi. So now we're gonna take a deeper look into what just happened here. So first the client sent a request to modify the pod spec. So previously there was one place that the pod specified its resources in the pod spec and everything used that. Now that the pod spec represents the desired state of the pod, the desired set of resources. After the kubelet observes this new desired state, if it has enough available capacity to do the resize, it will allocate the resources. That is sort of creating a reservation and an intention from the kubelet to actually go and make the changes. Next is the actuated state. So the kubelet, now it has the allocated resources. It's going to go and send the request to the container runtime to make the changes, to run the containers with the new sized values. And then finally, it will read back the actual running state from the runtime or from the container metrics to see what is the container actually running with. And that's what gets reported up into the status. So what does this look like if you're looking at the pod YAML? Again, in the pod spec, we have the desired resources. In this case, 200 mil of CPU, 200 megabytes of memory. And this is a case where a new resize just came in. So the allocated state here still represents the old values. And the allocated resources reported in the status is just the request values. And then finally, the status, container status resources field represents the actual resources running it. So in most cases, you probably just care about desired and actual. Allocated is kind of an internal detail that's surfaced for the scheduler. So what happens if a resize can't be actuated right away or allocated? The first option is that the resize is infeasible. This means that no matter what you do, it's never going to succeed. It might be that you're trying to resize a pod that's using a feature that doesn't support resize. Maybe you're requesting more resources than the total resources the node has. In this case, it will add a pod resize pending condition with the infeasible reason and a message explaining why it's infeasible. The next option is that there's not enough resources available to do the resize right now. But if we free up more resources, then it will become available. In this case, we say the resize is deferred. And every time resources are freed up on the node, for instance, if another pod is deleted, then the kubelet will retry the resize, and it will succeed at a later time. And then once the resize has been allocated, but not fully actuated, the resize becomes in progress. And this condition is usually very short-lived. Typically just 1 2-second pod sync cycle is how long it will take for the kubelet to recognize that the resize has been made and remove this. But there are cases where you can hit an error actuating the resize, and that gets surfaced through this in progress condition as well. So let's just look at a couple examples of those. Here's an example of a infeasible resize. So we can see, again, the condition type is pending. The reason is infeasible, and there's a message here explaining that the nodes, you're requesting more memory than the total node capacity. And here's an example of an in-progress condition surfacing an error that the new memory limits are below the current usage. This is actually a case where the kubelet has some best effort protection to prevent an kill when decreasing memory limits. So in this case, the kubelet recognizes that the new limit is below the usage, and so it will not actually apply the changes. I say best effort because there are some race conditions here where if usage kind of spikes right when the kubelet is applying the changes, it could still end up triggering an kill. And so if you are really sensitive to disruption, I recommend being careful with decreasing memory limits. So next I want to talk about a few of the limitations of in-place resize. The first is that resizes are atomic. So suppose you have a pod with a bunch of different containers and you're resizing a couple of those containers. Maybe the kubelet has enough resources available to resize one container, but not all of them. In this case, it still won't resize just that one container because the allocation step is all or nothing. Either it can allocate resources for the whole desired state, or it will keep the pod in deferred. Next, currently only CPU and memory are resizable. The quality of service class, or QoS class, this is like your best effort, burstable, or guaranteed. That's not allowed to change when you resize a pod. So for instance, guaranteed means you have CPU and memory limits, or CPU and memory requests and limits that are equal to each other. You can't now decrease your requests below your limits because then it would no longer be a guaranteed pod. This also means that you can't add resource requests to a best effort pod because then it would move into the burstable category. Let's see, container types, only main containers and sidecars. We don't support removing resource requests or limits today. There is an open PR for this, so it might make it into 136 and Linux only. In terms of unsupported features, there's a few things. We don't support resizing pod level resources if you're using static CPU or memory policies or have a swap enabled pod. These are all things that we expect to add in the future. Actually, pod level resources, I just yesterday approved the PR to go into alpha in 135, it will be in alpha. And then, yeah, I already mentioned the memory limit best effort protections. So now let's talk about vertical pod autoscaler, which we touched on earlier. So before we had in-place resize, if you, the way resize worked is it would delete a pod with this is with the recreate mode. It would delete the pod, wait for the workload controller to recreate the pod, and use a mutable admission controller to bring the pod up with the new resource values. There's now in beta this option, in-place or recreate, which first attempts to do an in-place resize. And only if that resize fails does it fall back to the recreation mode. In the future, we'll probably also add a fully non-disruptive in-place only mode. And now that we have the ability to do non-disruptive updates, we can be much more aggressive with how frequently we're doing the resizes with VPA. And so make that much more responsive to changes in usage. Another feature that's coming soon to VPA is CPU startup boost. So Mofi touched on this in the example use cases. If you have an application with an expensive initialization phase, then you can boost the CPU resources during that startup phase, and then after some preset conditions, drop it back down to the normal level. And then kind of from there, VPA can continue to adjust the resources dynamically. So I think it was just last week was the Ray Summit where they announced the Ray Autoscaler v2. And Ray Autoscaler v2 has native integration with Kubernetes In-Place Resize for faster task and actor startup or scale up, better utilization, and improved reliability. They did some early testing on some existing benchmarks and found that in this one benchmark, there was a 30% improvement in efficiency using In-Place Resize.
And this was your one and only AI adjacent slide, so.
So once you resize a container, that doesn't necessarily mean that the application is immediately able to use those new resources. So here's a bunch of popular languages with runtimes. And in all of these cases, CPU changes are immediately made available to the runtime. We actually worked with the Go development team recently to enable the Go runtime to automatically detect CPU limits to set max procs, Go max procs, and that does polling so that if those limits change, it automatically changes them to the new values. In the case of Python and Java, they don't currently update the total heap size when the memory limits change. So these are cases where you would want to set that restart policy to restart for memory changes there. And we are in conversations with some of the Java development team to make that more dynamic as well. I also wanted to mention, like, you don't see languages like Rust and C up here because they don't have runtime in the same way. And so kind of by default, the new resources are immediately available in those cases, but that's going to depend a lot on what other frameworks and tools you're using within those languages. So I just want to briefly talk about what's next for In-Place Resize. There's a bunch of features that aren't supported today. We want to change that. So I already mentioned pod level resources support is coming soon. Topology manager support, this is your static CPU and memory. We're in active design phase, I would say, working on getting a KEP out for that. Scheduler coordination, there's some race conditions with the scheduler today. Since the kubelet is managing the resize, that sometimes the scheduler and the kubelet can get out of sync, which could result in a pod getting scheduled to a node when there are no longer resources available for it. So we have a proposal, hopefully get that into 136. And then we also want to add support for preemption or capacity requests. So you do a resize, scale up, there's not resources available for it, so it enters the deferred state. If that's a high priority workload, we want to add the ability to automatically preempt or evict a lower priority workload to make space for that high priority workload. A few more things that are under discussion, supporting more resource types. Not currently planned, but if we have enough demand for, say, resizing ephemeral storage, that's something we could add. And then the next one is, hopefully you've all heard about DRA at this point. I know there's been a lot of talks on the topic here. It would be cool if you could dynamically add accelerators to a pod or any number of other resources that are managed through DRA.
Yeah, then you can call it dynamic relocation. That could be a lot of fun.
Or IPPR for DRA.
Uh-huh.
And yeah, the last one, workload resize. This is the idea that, like, you've got a deployment, you want to resize all the replicas in the deployment. maybe we could have a request that you can send to the deployment object that automatically propagates to all of the replicas. I'm not sure we're going to do this, honestly, because this is a case where probably you should just be using VPA or some other controller to be managing the replicas in that case.
All right, so let's take a look at some of these things a little bit more in action. So Tim talked about VPA. So I have a VPA object in my cluster right now. So if I do get VPA, you should see I have a VPA that is, the mode is in place or recreate. So same idea, if you can recreate in place, do that. If not, fall back to recreating the pod. And you can see the VPA have been running for a few hours. And again, the way VPA works, it runs, looks at the usage, and gives you a recommendation of what should be the state be. So in this case, the VPA has come back with 1.1 CPU and about 200 megabytes of RAM as the recommendation. So if I take a look at the object a little bit closer, so VPA demo -o YAML, you would see that VPA object is max allowed has been set with some numbers. But after some time, it came back with a recommendation. The way VPA object would work, once the recommendation has been there for a while, it will actuate that into your pod, update the pod. So I have a pod as well. So if I take a look at VPA-O YAML, you would see that in this case, I have a pod that has some resource and limit set. So, but after some time, the VPA object actually changed the request and limit because it's been running for 10-ish hours. So that's kind of like the VPA use cases. VPA is going to be probably super powerful with In-Place Pod Resize. But for KubeCon, I wanted to do something a little bit more fun where we can like have like a UI to see these actuations happen. So I built a small website where this application that is being currently served, we can take a look at the resource and limits of that application, right? And also I can change those numbers to something else. So if I go do that, you would see that I just updated, because the memory also changed, the restart count went up by 1. I can do other things. I can do even higher memory, higher CPU, and ask for it again. And you see the numbers update, and the allocated is still not updated because it's still resizing. And because I changed the memory, the pod is going to restart. So it's going to take a few seconds, and we should see the restart count go up to 5.
Stuck in pending.
Yeah, probably. So if it's stuck in pending, or it's just like restarting. No? Okay. It is currently running, apparently. All right, just quick refresh. Live demos, fun. Okay.
This is a good opportunity to look at the pod status, and we can see what the reason it's pending is.
Autocomplete is get PO-N IPPR, IPPR-O YAML. So the block team had shown earlier of the status and conditions, we can take a closer look at those right now. So in here, we see node didn't have enough resource. So it got stuck in pending. So what is happening is I have a single node with 8 CPU and 32 gigabytes of RAM, and I ask for resources that doesn't currently exist, right? So we're stuck in that specific pod resize pending. If I ask for a smaller size, actually, it will then fix itself, figure out how to give me that resource. So you see the restart happens. If I go ask for a bunch of resources again, I'm going to try that one more time with asking for a bunch of resources. I should get stuck, potentially, pod resize pending. Yeah, pod resize pending. And one of the things, so right now I'm in deferred state. I don't have enough resource to give me the resource I'm asking for. But if you were paying attention earlier, you would see that I told earlier that I have this echo server pod, which is just a placeholder. So what I'm going to do, I'm going to k-delete-f, k8s, echo server, echo deployment. And I'm going to have to do it kind of quickly, because the moment I delete this should actually immediately go in progress to running state, right? Because the resource became available, controller saw that I have now resource to make that happen. From deferred, it went to actuated and running. Now, again, I thought it'd be actually a lot of fun if people were to just all go in and start messing around with this cluster. So what I did, there's a QR code. You could all go to this web page and start modifying the resources, okay? I promise you'll not be able to break it, and if you do break it, that's actually great. Then you have a nice bug, and then we can go fix Kubernetes even better. So yeah, everybody, this is going to be up for basically the next couple of days. So anytime you're bored, you can go in and start messing around with the resources. And I'm going to keep this URL up. And in the meantime, we can, I think, take a few questions. Thank you so much for joining this talk. All right. I see. I think someone is walking towards the mic. That might be a question. All right. Yes. If not, everybody got it 100%, and no questions are left, which is great too.
Yes, the question I have is, is this infrastructure, are there any plans to extend this to PVCs, be able to dynamically allocate PVCs on an already existing pod?
The short answer is no, there are not currently any plans for it. This is all kind of hot off the press, so we're excited to see how people are using it and start taking those feature requests.
Yeah.
So that's definitely something we could think about in the future, but it's not currently on the roadmap.
Yeah. The reason I mentioned this is, I have a stack that uses it's meant for layering file systems on top of existing PVCs, and right now I have a hack which basically creates a new pod just for having a mount so that I can layer on top of it. It would be awesome if I didn't have to create a new pod every time I want to do one of these file system layering things. Anyway, thank you.
Yeah.
I just realized we never mentioned that this is all going GA in 135.
Great, thank you for the talk. My small question is, will VBA be able to do the in-place resize on a pod basis, or it is still just how VBA works on a deployment or on a replica set basis? And if it is still not implemented on VBA, is there any currently working on or in progress framework that can automate the pod itself, the resize of the pod itself instead of the controller that it works with?
There's a lot of echo in the corner. I don't think I heard it properly what you said.
Can you speak up a little bit?
Okay, so is it better now?
Yeah.
Okay, so for the case of the usage of VBA, will the VBA be able to work on a pod level, or it will work only on the controller that works on that deployment or a stateful set or any of these? And if it is still on the controller level, is there any in-progress framework that is being working on to work on the pod level resize?
Yeah, so right now, VPA's recommendations so it says, I'm going to resize these pods. Here's the resources that it should use. It's going to apply that to every replica in the controller, in the workload. It's on the roadmap to do that, to have a different recommendation per pod. I believe the plan is that that's only going to apply to daemon sets. So each daemon set instance can have its own size. This is in case you have different nodes or nodes with variable demand. But if there's a strong use case for bringing that to other types of workloads as well, I don't see any reason we couldn't.
Thank you.
You mentioned that the allocation is all or nothing.
Yep.
Will one pod being stuck in an infeasible state block all of the other pods from resizing? Okay.
So it's all or nothing per pod. So within a pod, if you make, you change CPU, you change memory, you change requests and limits of multiple containers, all those changes are all or nothing. But if you resize 3 different pods, it could accept one of those pods and not the other. Does that answer your question?
Okay, yeah, I think I thought the all or nothing was per node. It's across
per pod.
containers in one pod. Okay, thank you.
Hey, great presentation, folks. Thank you very much for sharing such a good things. And I had one question on the Ray Autoscaler V2. Is that something similar to what you guys have in multi-dimensional autoscaler and GKE?
So Ray Autoscaler V2, it's basically, Ray doesn't use any of the Kubernetes deployments and such. They manage pod directly themselves. Mm-hmm. So if you're running Ray on your Kubernetes cluster, and if that worker needs to get bigger or smaller, Ray Autoscaler V2 directly modifies the pod in place to do that. So it has nothing to do with multidimensional pod autoscaler. That's not using VPA or HPA. They're basically just Ray manages the pod themselves.
Okay.
They're Ray runtime, yeah.
Got it. So do you have plans to bring the multi-dimensional autoscaler into the Kubernetes world, or it is still?
I mean, in GK it exists, so we will.
In Kubernetes world, I'm talking.
Yeah, so we'll see. Now that VPA is more, we can have the conversation to see if multi-dimensional autoscaler should be donated to open source or not. But because until VPA couldn't do in place, it actually didn't make much sense to have a multi-dimensional autoscaler.
Since you guys have it out now, I think you should
exactly.
have.
So now that it works, maybe we can have a talk. We can figure it out. Yeah.
Thank you very much.
I think we're at time, so we're probably not going to be able to take any more questions live, but we'll be here, and so the people that have still more questions will be right outside the door. You can ask us as many questions as you'd like to. Thank you so much.